Welcome to another video on my Raspberry Pi, which is connected to this breadboard with a chip MCP23008 for I2C. Like I said, by this band cable connected to Raspberry Pi 1 running Raspbian Linux, programmed in C, and connected by also serial cable to a Minicom serial monitor, which is, by the way, this cable, and network cable for VNC, which is then this cable. And lately I have been trying to get I2C running, and I found some problems because I have a test running. Well, I can run a test, and initially that went quite well. The program that I used didn't do anything. So with this chip and these LEDs, which should be a walking LED array controlled by I2C, whatever I did and have done so far doesn't work. So last time I continued with another program that I found using the wiringpi library. And if you've watched my videos on the Raspberry Pi, you have seen me using wiringpi before, but then in context of LEDs using Python. However, that hasn't worked either yet. And one of the things which I ended with last time is a surprising end, that I changed the program to see how it behaved or behaves, and that had some surprise for me, because it didn't do anything except waiting on a point in the program that I had not anticipated. So that is where it stands. It is, as you can see, connected with two probes to the oscilloscope. I intend to use Pi scope as well, again, because for some reason Pi scope gives slightly different result than the oscilloscope. Anyway, that's for introduction. I can, by the way, run the program. So let's see whatever happens. Oh, right, then it helps when I am in the right directory. So this is what happens. Well, on screen quite a bit happens, but on the hardware not visibly anyway. Alright, let's go to the screencast and see whatever I can do. So, as you can see, VNC, virtual network computing, the breadboard with the I2C chip. This is the SPI digital to serial analog to digital converter, which is not currently a project. And then oscilloscope, serial terminal, and this is what it is about. So I was talking about Pi scope. Before that I had to start the Pi GPIO daemon, otherwise I can't run Pi scope. So we go. And that is the oscilloscope, which has currently no input. Then last time I changed the program and I added some more stuff to it. So this 1024 is part of the old program. This is part of the old program. This not, this isn't, this isn't. All the printfs are my contribution. And why? Because I want to see how things work out. That said, I want to know how many it counts. So not only printf but also the bit. Where is the bit being counted? What is the count? And there this comes in. This is the output. So this for loop starts at 0. Then it starts counting until it reaches 10. So it has 10, but 0 to 9 is 10. Otherwise it would be 11. And now that I read this, it is very interesting to see also how far it counts. So instead of this, I could just as well print another one. Let's take this line for example and put it right here. And then have X printed. Now this is not the smartest way, I think, but this is the original, kind of the original setup, so I'll let it be. This is one X and this is another X. So this will give the count of the X. Then this will give the count of the other X. So that may be a little bit confusing, so I'm going to change that. The original program doesn't have the X or doesn't have printing, so I want to, let's put this inside. That said, I'm going to change this part to Y, so I'm not confused by which is which. That means that this one has to be Y as well. Bit can be bit, and that's it. So now I have an X and Y and a bit. That should be enough to avoid confusion anyway. So now time to compile. And one of the things that I corrected last time is that I have to link everything to the wiringpi library. So there it goes. This should go fine. Yes. Then now let's see whatever happens. Here you see a response here. Do you see a response here? Well, X is 0. X counts to 9. That is completely correct. That means that it sets 100 plus X to pin mode, to output. I'm fine. Then
starting with Y. So here it enters this loop. Bit goes to 9. That's correct. It writes 100 plus bit to an address. Oh wait, that I doubt that that is correct. Hold on. Because here I am talking about an X, and an X is, in this case, if I'm talking correctly, a Y now. So I have to change this into a Y. And we compile. And let's see again. And here things go awkward, because I don't see anything here happen, but here it stalls completely. It says a delay of 1. Well, 1 is extremely short. It's a millisecond, if I'm correct. So let's quit this and then do sudo I2C detect -1 yes minus yes 1. And this is what I'm afraid of to see, because this this 0x20 is once again completely zero, out of order. Now if we look here, we definitely see clock and data pulse. So which is which? And now look at GPI something, PI scope. That changes too. So the GPIO is getting signals. The oscilloscope gets signals. But why is this 0? I really don't get it. I can add some other control, which is right here, because the last thing that is printed is after delay, which is right here. So I still don't know what's wrong here. So I don't know if this condition is met or not. So that is what I'm going to change. Opening bracket, of course. Then another one, and I say print have while. That should be sufficient because I have only one while loop. So if I say while, I know I'm inside the while. And closing brackets. So now I at least know when I'm inside and how long I'm maybe inside, but let's do it this way. So this means that I need another compilation. Yes, and other run. Alright. So it gets stuck in the while. And let me add a new line so the screen doesn't get cluttered all over, which is the case now, as you can see. Alright. So compile, start. Alright, while. So, alright, what is the purpose? Let's go down. So, for 1024 something, it sets a bit or prints a bit. Yes, it writes a bit to an address, and or yeah, I guess it is an address, because otherwise why would you write a bit? Or a register can be as well. And then you have a delay, and after that delay you read digital from the latest, from 1115, while it is 0. So you expect it not to be 0. Because while it is 0, you delay it for 1 millisecond. So something is a bit odd. And I see nothing on the Pi scope. I see nothing here. Go back to RaspberryPi detect, and I do see things on both Pi scope and the oscilloscope. And both on the clock and the data. Now, if I go back to the other program, the demo, it doesn't do, well, it does a little bit more. But previously it didn't do a thing. Absolutely nothing. So this is, yeah, this is a bit surprising to me that it at least does something, but looking at the LEDs, it still doesn't do a thing. So while it apparently does something here and here, considering all the activity that I see, why doesn't it do anything on the hardware? For that I'm quite curious, and I'm also surprised that I see this anyway, because I had not expected this. So while this is to be a program that uses wiringpi and should be a solution for testing I2C, which it does, the other program is a demo as well, and more or less had the same purpose, showing that I2C works. That said, I see everything going up and down. Let me, yeah, I see here some break signal. Let me increase the voltage level. So select channel 2 and that is data. But this is now for 2 volts. 1 volt even. Not even 2, 1. So it's a very low voltage. And alright, so much for this one. Now let's go for this one. Yeah, well, that doesn't work. Go back here. So something is working, but it's still a mystery why. And the bigger mystery is why doesn't the circuit work? Did I make some wiring mistake? Time to find that out, because this shows that certainly things do work. Alright, now looking at this result, which is not this program by the way, let's quit this for now. Let's concentrate for a little analysis of this part. Well, first this one. This says 100 plus all this plus 0 to 9 for output. Okay. That leaves out pin mode is directly related to Raspberry Pi. So it sets a pin, some pin, to be output. Let's take a look at using another terminal or another, yeah, let's take another tab. This one. There's no pin mode in here, although it sets all pins to output. All pins. And that's all it does. So this is a bit strange. Well, this one, this is actually the program that is supposed to let this run the LED output, so you don't need input. So in that perspective, yes, it does. So that is actually correct in that way of viewing. Then go back here. It says only some pins to output, although, well, over 100. And this does nothing. So let me check on the pin numbering of the Raspberry Pi, because now I start wondering, does it do anything at all? I typed it over. No, I didn't type it over, I copied it into it. Or did I? Then 100 would not make any sense. That's a good point. Where did I go wrong? Alright, I did not make any typing mistakes, so I will assume this is alright, although to me it's a bit strange, but anyway. It does tell me, by the way, that I should load GPIO load I2C. So whatever, if it takes unable to load as the device tree enabled. Well, it is already done, because if I look here, as I've done before, by the way, let's check for it again. I would be very surprised, by the way, if it didn't. Yeah, here, loading. So everything is loaded. So I'm very happy to see that anyway. So that does not explain why things go the way they go. And another thought that I have is, why don't I get rid of the while? It probably is there for a good reason, but on the other hand, if I run this program, which is this one, this is what happens, which is not really a lot. And when I now run this instead, alright, something works. So not quite sure which way to go. Oh yeah, that said, there is this one and this one. And this actually is what it is, the schematics of what you can see here. From this point of view, from this camera point of view, you can't see a lot. You would see though if the LEDs would work. But I still have to find out which is which, how the wiring is set. I don't have any values put inside here. The original program also doesn't really show more info, unfortunately, unless I've overread it, which is also possible. Oh, this is a nice one. It is a 3-bit address select port. So when I and 8 chips giving you capability of 128 I/O pins. So this is per one is, if I calculate it correctly, is 16 I/O pins extra. And this is not answering. So let's get back one more time, since time is running out fast again. Uh-oh. Yeah, this works. Nope, not answering. Okay, I'll have to leave it at that. Some surprising stuff done, but in the end, yeah, only this works, kind of.
And with that, it is once again time to say goodbye. Although some clarity is there, it doesn't work yet the way I like, the way I want. So thank you for watching. If you like this video, please subscribe to my channel, give the video a thumbs up, and give a comment, leave a comment if you like. You can also follow me on Twitter. If so, please like and leave a comment, retweet. You can also follow me on Instagram. Please like and leave a comment. Please donate to keep to show your support and keep videos coming to you. You can also become a patron and by monthly pledge have your name mentioned either on my website or on my website, and with my videos depending on the pledge you make. And this is going to be continued, obviously. Once again, thank you for watching, and bye bye.